Hello everyone and welcome to our channel. My name is Gokul and today we are presenting our MSIC subject project, the reverse car parking sensor circuit. Have you ever been in a situation where you are reversing your car in a tight parking spot and you are just not sure how close you are to the wall behind you? Scratches, dents and minor collisions while parking are some of the most common problems drivers face every single day. And the solution everyday problem is exactly what we have built today. A reverse car parking sensor is a safety device that helps a driver understand how far or how close their vehicle is from an obstacle while reversing. It alerts the driver in real time using visual indicators, in our case, colored LEDs, and a buzzer alarm, so that the driver knows exactly when to stop. In this video, we are going to walk you through everything about this project. We'll start with how the circuit actually works in detail. Then we'll talk about the real world applications of this technology and finally wrap it up with our key takeaways. The circuit is built using basic and easily available electronic components: an IR sensor pair, op-amp ICs, potentiometers, resistors, LEDs, and a 9-volt battery. No microcontroller is needed. It's a pure analog circuit, which makes it a anyone studying electronics. So, without further delay, let me hand it over to Deepam, who will explain the complete working of this project in detail.
Hello everyone, I am Deepam and I'll be explaining our reverse car parking sensor circuit. The project is built completely using analog electronics on a breadboard. Here we are using an infrared sensing arrangement for obstacle detection. The infrared transmitter continuously emits infrared rays, and when an obstacle comes near the vehicle, the rays reflect back and are detected by the receiver. The detected signal produces a changing voltage which becomes the main sensing input of the circuit. At the center of the circuit, we have LM324 operational amplifier IC used as a comparator. The comparator compares the sensing voltage with preset reference voltages. We are using three potentiometers to set different voltage threshold corresponding to a different distance level. The three LEDs indicate different conditions: green for safe distance, yellow for caution, red for danger or stop condition. The entire circuit runs on a 9-volt supply and demonstrate a simple but effective reverse car parking indication system without any programming or microcontroller. Now let's understand the working. As the obstacles come closer to the sensor, more infrared light is reflected back. Due to this, the sensor output voltage increases gradually. In our demonstration, we are varying the voltage manually using the potentiometer, which simulates the same voltage change produced by the sensor during real obstacle detection. Initially, the voltage is low, no comparator threshold are crossed, and LEDs remain off. As the voltage increases and crosses the first threshold, the green LED glows, indicating the object is within the range. When the voltage increases further, the yellow LED glows, giving a caution warning. Finally, when the voltage crosses the highest threshold, the red LED glows, indicating the stop or danger. So the changing voltage here behaves exactly like the changing sensor output in an actual reverse car parking sensor. Now, I will be handing it over to Purvesh, who will tell you about the real world application of this technology.
Thank you, Deepam. Hi everyone, I'm Purvesh and I will be covering the many real-world applications of the reverse car parking sensor because this small circuit has a huge impact in the real world. Industrial work vehicles and forklifts. In warehouses and factories, heavy vehicles like forklifts operate in narrow corridors. Proximity sensors based on this same pricing help prevent collisions with shelves, walls, and workers, improving workspace safety significantly. Another application is smart home automation. IR-based proximity sensors are used in automatic door systems, smart lighting that turns on when someone approaches, and security systems that detect intruders near entry points.
Start.
Assistive technology for differentially abled individuals. Proximity sensing circuits can be integrated into wheelchairs or walking aids to help differentially abled individuals avoid obstacles in their path, improving their independence and safety. Thank you so much, Gokul, and thank you, Deepam, for that brilliant explanation. So let's quickly summarize what we covered today. We built a reverse car parking sensor circuit using an IR sensor pair, three LM741 op-amp comparators, potentiometers, resistors, and three colored LEDs. The circuit detects how close an obstacle is and progressively lights up a green, then yellow, and finally a red LED with a buzzer as the distance decreases. Given the driver a clear real-time warning system. This project taught us some very important concepts in electronics, how op-amps work as comparators, how voltage dividers function, how IR sensors detect obstacles, and how we can combine simple components to solve real practical problems. The best part about this circuit is that it requires no programming whatsoever. It's a pure analog circuit that anything learning electronics can build and understand. We have discussed the applications of this technology and truly everywhere from cars to robots to smart homes to factories. We hope this video was informative and helpful for everyone watching. Thank you.